Hi there everyone, welcome to my channel. So in this video, we will talk about the history of data structure. Before we start, I would like to say thank you so much to all my viewers, silent viewers, and supporters in my channel. Thank you for watching my videos. If you are new with my channel and then you like this video, please hit the like button. Don't forget to share and please support my channel guys by clicking the subscribe button. So let's begin. History of data structure. The history of data structures dates back to the early days of computer science and programming. As computers and programming languages evolved, so did the need for efficient ways to store and organize data. Here is a brief overview of the history of data structures. Number 1. Arrays. Arrays are one of the simplest and oldest data structures. They provide a way to store a fixed size sequence of elements, typically of the same type, in continuous memory locations. Arrays offer constrained time access to elements but have a fixed size, making them inflexible for dynamic data. Number 2. Linked lists. Linked lists were developed as an alternative to arrays to overcome their fixed size limitation. A linked list is a collection of nodes where each node contains data and reference to the next node in the list. Linked lists provide dynamic memory allocation and efficient insertion and deletion operations but have slower access times than arrays. Number 4. Stacks. Stacks are abstract data types that follow the last in, first out or LIFO principle. They can be implemented using arrays or linked lists. Stack operations include push, adding an element to the top, and pop, removing the top element. 4. Queues. Queues are the abstract data types that follow the first in first out or FIFO principle. Similar to stacks, queues can be implemented using arrays or linked lists. Queues operations include enqueue, adding an element to the rear, and dequeue, removing the element from the front. 5. Trees. Trees are hierarchical data structures with a root node and a set of child nodes. Each node can have 0 or more child nodes. Trees are commonly used to represent hierarchical relationships or to provide efficient search operations. Different types of trees include binary trees, binary search trees, EVL trees, and B trees, among others. 6. Hash tables. Hash tables, also known as hash maps, are data structures that use hash functions to map keys to values. They provide efficient lookup, insertion, and deletion operations. Hash tables are widely used in various applications, including databases, cache, and dictionaries. Number 7. Graphs. Graphs are nonlinear data structure consisting of nodes, vertices, connecting by edges. Graphs are used to represent relationships between objects such as social networks, computer networks, and transportation networks. They can be directed, edges have a specific direction, or undirected. Over time, many other data structures and variations have been developed, including heaps, priority queues, tries, skip lists, and more. The choice of data structure depends on the specific requirements of an application, such as the type of data, expected operations, and performance considerations. Data structures continues to be a fundamental topic in computer science and extensively studied to optimize data storage, retrieval, and manipulation. Okay guys, so this is the end of my report and presentation about history of data structure. Thank you so much for watching this video. I hope that you have learned something new, no? So don't forget to like, share, and please support my channel guys if you are new by clicking the subscribe button. See you in the next video tutorial guys. This is your friend Jake saying bye bye for now.